Hey, well, welcome back, and we will be looking at a new topic, and the topic is on just a minute. Wanna bring it up? Okay, okay, let me just do this one. Just a minute, please. Okay, this is the topic that we're looking at today. Okay, I put this one on slideshow and then big comments. Okay, so okay, so this is what we want to look at today. I want to look at and put this here. Let me close this floating head. Okay, so we want to look at acids, bases, and salts. That's the topic that we want to look at today. Acid, bases, and salt. Okay, all right. Those of you that are just joining the channel or that are just joining us, we've been looking at JAM chemistry syllabus for some for a while now. We are looking at the syllabus topic by topic. So there are videos of all the topics that have been treated previously. So do well to look at those videos so that you can build on knowledge and as we move along. So we want to look at today acid, bases, and then salt. My name is Anjori Oluwafemi Excel. I have a bachelor's degree in chemistry from the University of Ibadan, the Premier University, you know. All right, so I have a PhD also in science education and a master's degree in environmental and analytical chemistry from the Redeemers University, Ede, Osun State. I'll be your teacher, and I hope you learn something valuable as we move along in this lesson. All right, let's look at our lesson objective for this topic. Our lesson objective are one, by the end of this lesson, students should be able to define acids and salts and explain their general characteristics. Two, classify acids and bases based on their strength, origin, and ionization properties. Number three, describe the physical and chemical properties of acids, bases, and salts. And number four, explain key chemical reactions involving acids, bases, and salts, including neutralization and reactions with metals, carbonates, and ammonium salt. Okay. And the fifth learning objective is that we should be able to identify common examples and industrial applications of acids, bases, and salts. And finally, demonstrate knowledge of salt preparation method, including neutralization, precipitation, and titration method of preparing salt. Okay. All right. The first thing that we need to look at is what is an acid? Let's give a little definition of what an acid is. And we say an acid is a substance that produces hydrogen ion as when dissolved in water. It produces hydrogen ion when it dissolves in water. Examples of acids include hydrochloric acid, nitric acid, and then sulfuric acid. So we have HCl, HNO3, and H2SO4, and so on and so forth. So these are some of the examples of the acids that we have. Now, what are the general characteristics of acid? Number one, in terms of taste, acid have a salt taste, e.g., lemon juice, vinegar, and so on and so forth. These contain, they're natural product that contains acid, and they have a salt taste. So acid has a salt taste. Number two is the litmus test. Acid turns blue litmus paper red. And then in terms of conductivity, acid can conduct electricity in aqueous solution so they can conduct electricity in aqueous solution. And then in terms of reaction with metals, they react with metals to produce hydrogen gas. And then reaction with base, which is a very, very common reaction. They neutralize bases to form salt and water. Also, the pH scale of acid, they have a value that is less than 7 on the pH scale. Okay, so those are some of the general characteristics of the acid. Okay, let's look at the next one, classification of acids. Now, acid can be classified in 3 ways. Number one, based on their strengths. So based on strength, we can have strong acids and we can have weak acids. So strong acid, they completely ionize in solution. Example, HCl, H2SO4, even HNO3. Now, weak acid, they partially ionize in solution. Example is ethanoic acid, CH3COOH, they partially ionize in solution. So based on strength, we have that classification. Also, based on origin, we can classify acid to be organic acid and inorganic acid. Organic acid that derive from living organism, e.g. citric acid, lactic acid, and so on and so forth. Now, inorganic acid, on the other hand, are mineral-based, e.g. nitric acid, hydrochloric acid. Now, the third classification is based on the number of ionizable hydrogen atom. So based on this, we can have what we call monoprotic acid, which donates 1 proton. Example, HCl. We can also have what diprotic acid, which donates 2 protons, that is H2SO4. We can also have what we call triprotic acid, which donates 3 protons. Example, this phosphoric acid, H3PO4. So these are the classifications of acid based on strength, based on origin, and based on the number of ionizable hydrogen atom. Okay. All right. So what are the properties of acids? Let's start off with the physical properties of acids now. Now, in terms of their state, they can be solid like citric acid, they can be liquid like sulfuric acid, or gaseous like hydrogen chloride. In terms of solubility, physical property, most acids are soluble in water. Most of them are soluble in water. Now, looking at the boiling point and melting point, they vary on molecular structure. So the melting point and boiling point of acid vary on molecular structure. Also, based on odor, some acid have distinct pungent smell, e.g. acetic acid, So these are physical properties of acid. Let's look at the chemical properties now. Number one, reaction with metals. When acid reacts with metal, they will always produce a salt and hydrogen will be given off. Number two reaction is reaction with bases. Okay, number two chemical properties rather are reaction with bases. When acid combine or react with base, what you see happening is that they would form what we call salt and water, and that is a typical example of a neutralization reaction. So HCl reacts with sodium hydroxide, give us sodium chloride, and then water, okay? Reaction with carbonates is another chemical properties of acid. When acid reacts with carbonates, they'll produce salt, water, and carbon 4 oxide. So we can have a good example there of H2SO4 reacting with calcium carbonate to give us calcium sulfate, and then CO2 and H2O also produced alongside, okay? In terms of reactions with metal oxide, acid reacts with metal oxide and forms salt and water. Example, hydrochloric acid reacts with copper 2 oxide to form copper 2 chloride and water. You can see that depicted in the equation in the on the slide. Okay. So we can have that. Sorry, excuse me, please. Just pardon me. Do something. Okay. All right. Just checking. All right. So that's regarding their chemical properties of acids. Okay. Another thing that we need to look at is the common examples of acids and their uses. Common examples of acids and their uses. And if you look at an acid like hydrochloric acid, HCl. It is used in digestion and cleaning agents. HCl is a very important component of the human anatomy, specifically the human stomach, and it aids digestion, and it's also a very good cleaning agent. Also, it can remove tough and stubborn stains, okay? Then we have sulfuric acid. It is used in battery manufacturing and fertilizer. HNO3, nitric acid, is used in explosive and fertilizers. Acetic acid, which is CH3COH, is found in vinegar, which is a very good substance, also a very good solvent for so many things that we use them for. Okay, we use them for cleaning. We can also use them as a component in cooking and so on and so forth like that. So citric acid is another example of an acid, a common acid, and it is used in food preservation and soft drinks. Okay, in food preparation and soft drink. Now, industrial and everyday uses of acids include: one, industrial application. Acids are used in fertilizer production, H2SO4 and HNO3 to be precise. They are also used in petroleum refining. They are also used in electroplating and metal cleaning. Now, in the medical world, stomach acid, HCl, aids digestion. Ascorbic acid, vitamin C, is essential for the earth. Very, very essential for the earth. It does a lot of things. It helps to help our immunity when you are cold. When you take vitamin C, it's very, very good. It's a very, very good over-the-counter drug that we can always get to help our immunity and to help us with cold and catarrh, as the case may be. Okay, now household uses of acid include agrees with this. Why? Because of the harm it does to the environment when you release acid, into the environment. And so there are other components that have been introduced that are not as corrosive as HCl as cleaning agents in cleaning household purposes. So, like I said, vinegar is used for cooking and also for cleaning. In the food industry, acid like citric acid and acetic acid are very useful for as preservatives. And beverages like carbonated drinks contains phosphoric acid. So these are the industrial and everyday uses of acids. Okay, having said that, let's start off with the base now and define what a base is first. That a base is a substance that produces hydroxide ion when dissolved in a solution. So bases are substances that accept hydrogen ion or releases hydroxide ion in solution. Okay, so what are the general characteristics of bases? One, in terms of taste, they have a bitter taste, e.g. baking soda, soap, and so on. In terms of feel, they are slippery to touch, their reaction to litmus, which is the litmus test, it turns red litmus paper to blue. Bases also conduct electricity when they are in aqueous solution, and they react with acid to give a salt and water, which is a neutralization reaction. Bases they have a pH scale that is greater than 7, so it's upwards of 7. So that is where they feature on the pH scale. Okay. Classification of base. Now, bases can be classified based on strength to be strong base and weak bases. Now, a strong base is one that completely ionizes in solution, e.g. sodium hydroxide, potassium hydroxide. A weak base, on the other hand, partially ionizes in solution, e.g. ammonium hydroxide and then aluminium hydroxide. Now, based on solubility, we can also classify bases to be alkalis and then insoluble bases. Alkalis are basically bases that dissolve in water. They dissolve in water. So you have sodium hydroxide, you have potassium hydroxide, and so on. Insoluble bases, on the other hand, do not dissolve in water. Example are copper hydroxide and iron hydroxide. So what are the properties of bases? We have the physical property and then the chemical properties of bases. Now, the physical properties include based on state, they can be solid, e.g. sodium hydroxide pellets, calcium hydroxide, or aqueous, example like ammonium hydroxide. Now, in terms of solubility, Some bases are highly soluble in water, they're alkalis, while some of the others are not, they are not soluble, they are insoluble. Now, in terms of odor, some are weak bases like ammonia have a strong pungent smell, very pungent smell. And then in terms of texture, they can be slippery when dissolved in water. These are the physical properties of bases. Okay, let's look at the chemical properties now. They react with acid in a reaction called neutralization reaction to give us salt and water. Also, they react with metals, and when they do this, strong bases react with certain metals to form hydrogen gas, and that is what happens, reaction with ammonium salts. When bases react with ammonium salt, they will form salt, water, and ammonia gas is given off. So these are some of the chemical properties of bases. Let's talk about common examples of bases and their uses now. Common examples of bases and their uses. If you look at it closely, you see that sodium hydroxide is used in soap making and drain cleaners. Potassium hydroxide is used in alkaline batteries. Calcium hydroxide is used in cement and plaster, which are very, very important for in the building industry. Also, ammonium hydroxide is found in household cleaners. And then magnesium hydroxide is used as an antacid. Very, very important. When you have an acid burn or something, you need an antacid. So magnesium hydroxide comes in handy, and they are used in producing antacids. Okay. All right, industrial and everyday uses of bases. Industrial application includes soap and detergent manufacturing, paper production, calcium hydroxide to be precise is used in these. Textile industry makes use of ammonia in a solution. Medically, it is used as a component in making antacid for acid reflux, It's also used in medical soaps and antiseptics, in the food industry, the bases also find their relevance in the food industry. Baking soda is used as a leavening agent, especially for in businesses that makes use of flour and dough for making different items, confectionaries, and so on. So baking soda is used as a leavening agent, and it's also used in food preservation. Also, the uses of bases include cleaning agents like ammonia, sodium hydroxide can be used, drain cleaner and oven cleaners, okay, like sodium hydroxide. Food in the food industry, baking soda is used as I think I'm repeating that. Sorry about that. So also it is used in household also. Oh, I think I repeated that slide twice. Please pardon me. So these are some of the industrial and everyday uses of bases. Okay, all right. See. Now let's look at salts now. Salts are ionic compounds formed from the neutralization reaction between an acid and a base. General characteristics of salts include composition. In terms of composition, they are made up of positively charged cations and negatively charged anions. In terms of taste, many salts have a characteristic taste, e.g., sodium hydroxide, sodium chloride is salty. In terms of solubility, some salts dissolve easily in water, while others are insoluble. In terms of electrical conductivity, salt conduct electricity. When dissolved in water, then they act as electrolytes, okay? Now, their pH nature, they can be neutral, they can be acidic, they can be basic, depending on their parent acid and their base, okay? So that determines whether they'll be acidic, basic, or neutral. Now, there are different types of salts. We have normal salts, which is completely neutral, e.g., sodium chloride and potassium sulfate. Then we have acid salts, which contains replaceable hydrogen atom, e.g., sodium hydrogen sulfate. Then we have basic salts, which contains replaceable hydroxide ion, like bismuth hydroxide nitrate. Then we have double salts, which contains two different cations, And then we have complex salts, which contains complex ion, like potassium ferrocyanide and so on. And so forth. So these are the different types of salts that we have. Properties of salts. Let's look at the physical properties now. Most salts are crystalline solid. They are mostly crystalline solid. Now, in terms of solubility, it varies. Sodium chloride is highly soluble, while HgCl is nearly insoluble. That's in terms of solubility. In terms of melting and boiling point also, No, generally they have high melting and boiling point due to strong ionic bond that forms them, okay? Hygroscopic nature, some salt absorb moisture from the air, e.g. calcium chloride, while others don't, you know? In terms of colors, they can be white, like sodium chloride, blue, like copper sulfate, or other color based on the metal ion that forms them, okay? All right, so what are the properties of salt in terms of chemical properties now? We have, they react with water, hydrolysis. So some salts form acidic or basic solution in water. Ammonium chloride gives an acidic solution, and so on and so forth. Other ones may give basic, you know, depending on what their constituents is. Now, reactions with acid is another chemical properties of salt. When salt reacts with acid, what happens is that a new salt plus a new acid is formed. A good example is when sodium chloride reacts with H2SO4. You have sodium hydrogen sulfate, which is a new salt, and then HCl, which is a new acid that will be formed. Now, reaction with bases. When salt reacts with bases, the same thing happens. A new salt and a new base is also formed. So we have copper sulfate reacting with sodium hydroxide. You have copper hydroxide, a new base, a new salt, a new base rather, and then sodium sulfate, which is a new salt that is formed, okay? Reaction with other salts, which we call double decomposition. And when that happens, most of the time you have, you know, the salt, and then you have what's it called? You have the chlorides or other salts being formed accordingly. Okay, preparation of salts now. How do we prepare salt? Number one, we can do neutralization method to prepare salt. Acid reacts with base, they give us salt and water. Another thing that you must take note of is that neutralization method is mainly used for preparing soluble salts. So soluble salt of sodium, potassium, ammonia are prepared using neutralization method. Now, reaction of acid with metal is another way in which we can produce salt. So when you react a metal with an acid, you have a salt and then hydrogen being given up. This is also used for producing soluble salt, but not suitable for highly reactive metals like sodium and potassium, okay? Another way we can prepare salt is reaction of acid with metal oxide. So when acid reacts with metal oxide, which are bases, you know, when they react with acid, they will give us salt and then they will give us water. So this one is commonly used to prepare insoluble salt, okay? Another way to prepare salt is the reaction of acid with metal oxide, you know, reaction of acid with metal oxide. And when that happens, you have, you know, an insoluble salt that will be the resultant, you know, salt that will be produced. Okay, so insoluble salt is produced rather when acid reacts with metal oxide. Okay, all right. Now, other ones are reaction of acid with metal carbonate. When acid reacts with metal carbonate, they will also give us salt, and this is used to prepare soluble salts. Precipitation method or double decomposition reaction is another wonderful method that we can use to prepare you know, salts. And you know, two soluble salts react to form insoluble salt, you know, which is a precipitate and a soluble salt. So example is what we have here, AgNO3 and NaCl coming together. It forms AgCl, which is a precipitate, and then an insoluble and a soluble salt, which is sodium nitrate that will be formed. So this is used to prepare insoluble salts such as AgCl and barium sulfates. Okay. So another way we can produce salt is what we call direct combination of the elements. So the elements can also directly combine in the case of iron and chlorine, and then you have a salt being produced, and it is used for highly reactive metals and non-metals, okay? Even sodium and chlorine can combine directly to produce a salt. We can also produce salt or prepare salt by titration method. This is for soluble salt of group 1 and ammonium salt. So a strong acid is titrated with a strong base, and the solution is evaporated to obtain the salt. Example, H2SO4 plus NaOH, you know, and you have the salt being produced, and this is used for preparing pure soluble salt, okay, for preparing pure soluble salt. Okay, all right. Now I'll try to do a comparison of salt preparation method And these are the different methods that we can use to prepare salts, and then the suitability and then examples. For neutralization, it is used for preparing or soluble salt. And then you have an example there. Then for acid and the metal, it is used for preparing soluble salts also, have examples in zinc chloride and magnesium chloride. And we have an example there. And I just looked at all this method one after the other, so we can see the ones that are suitable for producing soluble salt, the ones that are suitable for producing insoluble salt, and so on and so forth, okay? So common examples of salt and their uses. What are the common examples of salt and their uses? Now, the first one is sodium chloride. That's a very common salt. It is a table salt and it is used in food and also in preservation. And we have calcium carbonate, which is used in cement and tacit. Then we have copper 2 sulfates used in agriculture as a fungicide, and sodium bicarbonate, baking soda used in cooking and medicine. Then we have ammonium nitrate, which is used in fertilizers and explosive. Okay. Industrial and everyday uses of salt. Industrially, we can use salt for manufacturing chemicals and glasses or glass. Na2CO3 is a very good example. It's also used in metallurgy and dyeing process. Salts can be used in the medical world, and like salt like Epsom salts, are used in medicine, for so many things. And sodium bicarbonate is also a very good example of a salt that can be used to treat acid reflux, So they are used in producing antacid that treats acid reflux. In the food industry, salt are used as preservative and flavor enhancers, and they are also used in food processing and curing also. Okay. Also it is used as water softener, example is Na2CO3 and as cleaning agents and detergents, So these are also the uses of salt. Okay. Right. See, so we want to look at the basicity of acids now. But before we jump into basicity of acid, don't forget what we have touched on so far. We have looked at acid. We have defined what an acid is. We have also looked at the properties of acids, physical, chemical properties, their uses. We've also looked at bases. We've defined what a base is. We've equally looked at the properties, physical and chemical properties of bases. And then we've also touched on their uses also. And we also looked at salt. We looked at the various methods we use in producing or preparing salt. We have looked at their industrial uses and their everyday uses as well. So if you have any question based on this, please put your questions in the comment section and then I will react to them accordingly. Thank you very much. All right, let's move along to basicity of an acid now. Basicity of an acid refers to the number of hydrogen ion an acid molecule can donate in an aqueous solution. The number of hydrogen ion an acid molecule can donate in an aqueous solution. Now, basicity of an acid refers to the number of replaceable, there's another definition now, by the way. Basicity of an acid refers to the number of replaceable hydrogen atoms in one molecule of the acid. Now, it determines how many hydroxide ions are required to completely neutralize the acid. Basicity is an important property in acid-base reaction and industrial application. Okay. Now, how do we classify acid based on basicity? We can have what we call monobasic acid. Monobasic acid have basicity of 1. They donate 1 hydrogen ion per molecule. Example, HCl, HNO3, and acetic acid, CH3COOH. Then we have dibasic acid. They have a basicity of 2. So example, they H2SO4 and H2CO3, Then we have tribasic acid. This one donates 3 hydrogen ion per molecules. Example is H3PO4. Yeah, phosphoric acid. Okay. So that's that in terms of classification of acid based on basicity. Okay. Let's look at another one. Methods of determining basicity of an acid. We can determine basicity of an acid through different methods. Number 1 is theoretical determination based on molecular formula. So we identify the number of ionizable hydrogen atoms in the chemical formula. Example, H2SO4 equals to 2 replaceable hydrogen ion. So their basicity will be equal to what? 2. Straightforward theoretical determination. Now, another way we can determine basicity of an acid is through ionization in water, which is the electrolytic dissociation method. Now, what we do is that we observe the number of hydrogen ion released in solution. Example, H2SO4 dissociates in 2 steps. First, you have the hydrogen ion, then the hydrogen sulfate ion, then you have the hydrogen sulfate ion dissociating further to the hydrogen ion and then the sulfate ion. Since it donates to hydrogen ion, the basicity of that acid is 2 based on the ionization in water. Okay, based on acid-base titration method. Based on acid-base titration method, we can have the acid is titrated with a strong base, sodium hydroxide, and the number of molecules of base required for complete mineralization is determined. So we have like HCl, which is a monobasic acid. When it is titrated against sodium hydroxide, you have sodium chloride and water being formed. So you have 1 mole of sodium hydroxide neutralizes 1 mole of HCl. So by implication, we say the basicity of that acid is what? Is 1. H2SO4, which is a dibasic acid, react with sodium hydroxide. Now, what we see is that 2 moles of sodium hydroxide will be needed to neutralize or to react with 2 moles of sodium hydroxide will be needed to react with H2SO4. So that means that with 1 mole of H2SO4 to be precise now. So that means that the basicity of H2SO4 in this regard is what? Is 2. This is based on acid-base titration. Okay. Based on salt formation also, we can also determine basicity of an acid. So we can say that the number of hydrogen atoms replaced when acid reacts with a base determines its basicity. It determines its basicity. Now, when you look at this closely, when HNO3 reacts with sodium hydroxide, what you have is 1 replaceable hydrogen atom that will be produced. So the basicity of HNO3 is just what? Is 1. When H3PO4, on the other hand, that's phosphoric acid, react with sodium hydroxide, you will need 3 moles of sodium hydroxide against what? 1 mole of what? Of H3PO4. So 3 replaceable hydrogen atoms will be needed or will be used up, for this salt, for the salts, of Na3PO4 to be formed. So from that, we can see that the basicity of H3PO4 is what? Is 3. The basicity is 3 based on that. Okay. Now, let's quickly summarize this lesson and see what we have learned so far. Now, we've been able to look at acids and we have defined what they are. We have given a general property for acids and then their classification based on strength, on origin, and also ionizable hydrogen atoms. We have also looked at common uses of acids and we've touched on that. Okay. We equally looked at bases and we defined what they are. We looked at their general properties and then we classified them based on strength and based on solubility also. Then we looked at examples, and their uses, accordingly. We also touched on salts and we looked at salts and we defined what they are. We gave a general properties for salts, then the types of salts that we have, normal, acid salt or acidic salt, basic salt, and then double salt and complex salt. So we looked at this one after the other, and we explained them and given examples, suitable examples accordingly. And then we now looked at, key, what's it called? Reactions. They are key chemical reactions. So we looked at acid, metals, acid plus base, and so on and so forth. So we looked at these, and we also touched on different ways in which salts can be prepared through neutralization, precipitation, reaction of acid with carbonates, and so on and so forth. So these are all that we have been able to look at in the course of this teaching. Please, if you have questions based on what I've taught so far, or based on any area that you're not so clear about, please let me know in the comment section, and I will gladly reply and put whatsoever it is that is not clear. I'll make it clear for you. Okay. All right. Let's quickly evaluate this lesson by looking at these questions. Which of the following is a general property of acid? to look at the options that we have there and tell me what is the answer. And please put what you feel is the answer in the comment section, and I will look at it and respond accordingly. The strong acid is one that's dash. So you tell me what your answer is in the comment section. Which of the following is a weak acid? So look at the options provided and let's make a choice and let me know what you feel is the right answer. Which of the following is an insoluble salt? Okay, so the options are there. Look at the options carefully and tell me what you feel the answer is in the comment section. What is the reaction of a base with ammonium salt called? Okay, talked about this in the course of the teaching. So please look at it, pick the right answer, and share with me in the comment section. What is the reaction of the base with ammonium salt called? Oh, I think I repeated this question twice. Pardon me. Okay, so please just look at that and let's have the answer in the comment section. Now, what color change occurs when a base is treated with litmus paper? So look at it carefully. Let me know what you feel the correct answer is. And then what is the pH range of a basic solution? Is it 0 to 7? Is it exactly 7? Is it 7 to 14 or 1 to 10? So tell me what you feel the right answer is. And then which base is commonly used in soap making? So we talked about this while I was teaching. So please tell me what the right answer is and put it in the comment section. Thank you very, very much. All right. With that, we have come to the end of today's lesson, and thank you for listening and for watching. Please, if you have any questions, just like I said earlier, please put them in the comment section. I will do justice to them. Thank you so much. I'll see you in the next video.